Good morning, friends. Today we are going to see some MCQ on first law of thermodynamics. So let's start. In a free expansion of an ideal gas, the work done is in free expansion means external pressure. External pressure is zero. So we can draw a diagram. There is no external pressure. This is a spring. There is no external pressure. So work done equal to pressure into change in volume. So pressure equal to zero. So work done also zero. Option A is the correct answer. Next question. Heat given to a system at constant volume goes entirely into. Heat given to a system at constant volume goes entirely into. Constant volume. The volume is constant. So work done equal to pressure into change in volume. Volume is constant, then change in volume equal to zero. There is no change in volume. So change in volume equal to zero. So work done equal to change in volume equal to zero. So work done is also equal to zero. So by the first law of thermodynamics, delta Q equal to delta U plus work done. So we have work done is equal delta Q equal to delta U. So work done is zero. Work done is zero. So delta Q equal to delta U. So whatever heat is used, so heat given to a system at constant volume goes entirely into change in volume. Sorry, change in internal energy. Whatever heat supplied to the system is going to change in internal energy. Change in internal energy. So option B is the correct answer. Whatever heat is supplied to a system is used to change in internal energy because work done is zero due to the constant volume. Okay, so next question. If a system rejects 50 joule of heat, so we can draw a diagram. Gas contained in a container. This is a piston. So system rejects 50 joule of heat. Reject 50 joule of heat. Heat equal to minus 50. When heat absorbs, then the heat is a positive, and it rejects heat. If it rejects the heat, then heat is a negative. So we have to use a negative sign for rejection. And does work. System is doing work. System due to the expansion. Due to the expansion, system is doing work. Work done equal to 30 joule. No, work done is equal to 30. So first law of thermodynamics, we have to find out the change in internal energy. Change in internal energy we have to find out. So first law of thermodynamics, delta Q heat supplied is equal to change in internal energy plus work done. So change in internal energy is given minus 50. We have to find out change in internal energy. Work done is 30 joule. So minus 50, it becomes minus 30 is equal to change in internal energy. So change in internal energy equal to minus 80 joule. Minus 80 joule. So option A is the correct answer. Option A is the correct answer. So next question. A heat engine works between 400 Kelvin and 300 Kelvin. Which law governs energy conservation in it? Engine is there. We can draw a flow diagram. Engine is there. It takes heat. Engine takes heat from higher temperature source. That is the 400 Kelvin. And does work and rejects heat Q2 to the lower temperature sink. And in this process, it shows that energy conservation. Energy conservation. So first law of thermodynamics. First law of thermodynamics shows the energy conservation. Energy conservation. So option B is the correct answer. Option B is the correct answer. Next question. Which of the following quantities is a state function? Internal energy is a state function because it depends on pressure, volume, and composition. Internal energy depends upon pressure, volume, and composition, not depend on path. Internal energy not depend on path. Heat and work. Heat and work are depend on path. So internal energy is a state function. Option C is the correct answer. Next question. In an isothermal expansion, isothermal means temperature. Temperature equal to constant. That is a change in temperature equal to zero. So we can draw a diagram isothermal expansion. Expansion means work done is takes place. Isothermal expansion. Heat absorbed by the first law of thermodynamics, delta Q equal to delta U plus work done. So in isothermal expansion, work done is positive. So the heat absorbed equal to delta U plus, so sorry, in case, so change in temperature equal to zero. So here internal energy is directly proportional to temperature. So change in temperature equal to zero means internal energy also equal to zero. Internal energy is also equal to zero. Due to the change in temperature is equal to zero. So change in internal energy also equal to zero because internal energy is directly proportional to temperature. Internal energy is directly proportional to temperature. So heat absorbed equal to change in internal energy plus work done. But change in internal energy equal to zero. So heat supplied, whatever heat supplied is equal to work done, is used for the work done. Whatever heat supplied is equal to work done because change in internal energy equal to zero. So option B is the correct answer. Option B is the correct answer. Next question. The term work done by the system is positive. The term work done by the system is positive when this is a system. If expansion takes place, if expansion takes place, that is volume increasing, volume increasing, then work done is positive. Work done is positive. Volume increases means work done is positive. If compression takes place, if compression takes place, that means volume is decreasing. That means work done is negative. Work done is negative. So for this question, volume increases when expansion takes place. Expansion takes place and volume is work done is positive. Work done positive. Okay. So next question. When 500 joule of heat is added, okay, this is a system. Heat is added. Q equal to positive. If heat is added means heat is added means heat is positive. If heat is rejected means heat is negative. Here positive and heat is added. And 300 joule of work done. Work done by this system is 300 joule. If work done on the system means negative 300 joule. But work done by the system, work done by the gas is positive 300 joule. So internal energy. So by the first law of thermodynamics, delta Q equal to delta U plus work done. So delta Q is 50 joule. So internal energy you have to find out, and work done is 300 joule. Sorry, heat is 500 joule. Heat is 500 joule. So 500 joule minus 300 joule equal to change in internal energy. So change in internal energy equal to 200 joule. So option A is the correct answer. Option A is the correct answer. Next question. In adiabatic compression of an ideal gas, here option is given. So temperature remains constant, temperature increases, pressure decreases, work done is positive. In case of adiabatic process means heat supplied equal to zero. Heat supplied is equal to zero by the first law of thermodynamics. First law of thermodynamics, delta Q. Delta Q equal to delta U plus work done. So in delta Q is here 0, heat supplied is equal to 0. Delta U, here compression takes place. Compression takes place means work done is negative. Work done is negative. So delta U minus W equal to 0. So delta U, internal energy is greater than 0. Internal energy is greater than 0. That means final internal energy minus initial internal energy is greater than 0. Is greater than 0. Change in internal energy is greater than 0. So final internal energy minus internal energy, initial internal energy is greater than 0. Means internal energy is directly proportional to temperature. We know that internal energy is greater than internal energy is directly proportional to temperature. So temperature also increasing because internal energy is increasing. Internal energy is increasing means temperature also increasing. Temperature also increases in case of compression. Got it? So next question. The first law of thermodynamics applies to all processes. Thermodynamics law, first law of thermodynamics is applied to all processes. Cyclic process, adiabatic process, and reversible processes. Next question. The work done in an isochoric process. Isochoric process means volume is constant. So change in volume, work done equal to pressure into change in volume equal to 0. So work done volume is constant and change in volume equal to 0. So work done is also equal to 0. So option B is the correct answer. Next question. Which of the following is not a path function? We have seen earlier this question. So internal energy is state function and work heat are path function. Work and heat are path function and internal energy state function because it depends upon pressure, volume and composition. Not depend on path. Internal energy is not depend on path. It is a state function. Next question. Delta U equal to 0, del Q equal to 100, then work done is. We have first law of thermodynamics. Delta Q equal to delta U plus delta W. Delta U equal to change in internal energy equal to 0. Q is 100 joule. Then the work done is. So work done is equal to 100 joule. Option B is the correct answer. The first law of thermodynamics is also known as law of conservation of energy. Law of conservation of energy. Next question. The heat capacity at constant volume is defined as heat capacity. Heat capacity at constant volume equal to dq upon dt. Now this is the formula we have to remember. At a specific heat at constant volume is equal to dq by dt. We can replace it. Q can be replaced by U because in constant volume process, change in volume is equal to 0. That means work done equal to 0. So by the first law by delta Q equal to delta U plus W. So W equal to 0. That means Q can be replaced by U. Q can be replaced by U. So formula can be become Cv equal to du upon dt. So dq means heat, heat energy, and dt means change in temperature, and this is a change in heat. So we can stop here. Is there any comment or any question? Please let us know. Please subscribe our channel. Thank you very much.